guys, in this tutorial I'm going to show you another subnetting example. Hopefully it can help you with the subnetting section of your exam. So in this example, I have a network of 24.0.24.0/23 and I need to have three smaller subnets in this network. LAN A with 32 hosts, LAN B with 128 hosts, and LAN C with 60 hosts. First thing you need to do is to arrange your subnets based on the number of hosts required in each subnet. We start from the subnet that needs the highest number of IP addresses. In our case, it was LAN B with 128 hosts. Then after that, LAN C, and then LAN A. The second thing you need to do is to figure out the number of bits needed in the host portion of the IP address, and therefore you can figure out the subnet mask for that specific subnet. I always use this table to figure out how many bits in the host portion I need for a specific subnet. For example, if I have 1 bit in the host portion, I will get 2 IP addresses, but none of them would be available to be assigned to a host. In that case, if I have 1 bit in the host portion, I will get 31 bits in the network portion. Therefore, the subnet mask would be /31. If I have 2 bits in the host portion, I will get 4 IP addresses. 2 of them would be available to be assigned to a host. In that case, the subnet mask would be /30. How did I figure out the table? It's really easy. The first column is just adding up 1 to the number in the previous row. So starting from 1, 1, 2, 3, 4, and so on. The number of IP addresses is 2 to the power of the number of bits in the host. So 2 to the power of 1 is 2. 2 to the power of 2 is 4. However, you can actually figure out this column even easier. You only need to multiply the number in the previous row by 2. So 2 multiply 2, 4. 4 multiply 2, 8. 8 multiply 2, 16. 16 multiply 2, 32, and so on. The third column is the previous column minus 2. So 2 minus 2 is 0. 4 minus 2 is 2. And then the subnet mask would be 32 minus the number of bits. So easily you can figure out the subnet mask as well. However, the easiest way would be starting from /31 and then decrementing by 1. So 31, 30, 29, 28, and so on. Just be careful not to make a mistake when you are going through the rows. So now, using the previous table, I know that to have 128 IP addresses available for the hosts, I need 8 bits in the host portion. Therefore, the subnet mask would be /24. If I need 60 IP addresses in a network, I need 6 bits in the host portion, and the mask would be /26. If I want to have 32 IP addresses in a network, I need to have 6 bits in the host portion, and therefore the mask would be /26. So now we are ready to allocate IP addresses to each subnet from the base network address that has been given to us. There are really 2 approaches. One is using the binary representation, which helps you to understand the process, and the other one is using the dotted decimal representation, which is a faster process. I recommend you to start with the binary representation. Once you understand the process, you can start using the dotted decimal format. Now, in this slide, what I have done is just converting the base network into its binary representation. 24 is 16 plus 8, then 0, 24, and 0. Subnetting is borrowing from the host portion of the IP address that has been given to us. I have highlighted the network portion in red to remind me that I cannot borrow from that portion of the address. I can only borrow from the green part. So now all I need to do is to set aside a block of IP address for each subnet based on the number of host bits that it needs. Alright, now starting from the base network address of 24.0.24.0, I'm ready to allocate a block of IP address to LAN B. LAN B needs 8 bits in the host portion. Therefore, it will have 24 bits in the network portion. I have highlighted the host portion in blue. Therefore, as you can see, the network address would be 24.0.24.0/24. For the first host address, always set the rightmost bit in the host portion to 1. Therefore, the IP address would be 24.0.24.1. For the broadcast address, set all the bits in the host portion to 1. Therefore, the broadcast address would be 24.0.24.255/24. Now, this block is used up for LAN B. I cannot use any of the IP addresses from this block in any other part of the network. Therefore, I need to figure out what is the next IP address after the broadcast address that has been used in this network. It's very easy. Just add 1 to the broadcast address and you will figure out what is the next available IP address. The broadcast address from the previous block was 24.0.24.255. I converted it into its binary representation. Now I'm going to add 1 to it. Just I need to remember the binary arithmetic. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 0 and a carry on 1. Therefore, if I add 1 to this broadcast address, the result would be 0 plus a carry on 1. 0 and a carry on 1. All the way up to here. So here I have a carry on 1 from the previous add. So then the result would be 0 and the carry on 1. You can see the result here. Now, can you tell me what is the decimal representation of this number? Yeah, that's right. That's 24.0.25.0. This will be the base network for the next subnet. This time, starting from 24.0.25.0, I'm going to allocate a block of IP addresses for LAN C. LAN C needs 6 bits in the host portion. Therefore, it will have 26 bits in the network portion. I have highlighted the host bits in blue. Similar to the previous process, you will see that the network address would be 24.0.25.0/26. The first host address would be 24.0.25.1/26. And then for the broadcast address, all the host bits as 1. The result would be 24.0.25.63. Now, you tell me what would be the base network address for the next LAN. So again, to find the next available IP address, I need to add 1 to the broadcast address from the previous block. As you can see here, the result would be 24.0.25.64. This time I'm going to start with 24.0.25.64 as the base network, and then for LAN A I need 6 bits in the host portion, therefore it will have 26 bits in the network portion. As you can see, the network address would be 24.0.25.64, and the first IP address would be 65, and the broadcast address would be 24.0.25.127. Now, can you tell me, in case I need another subnet, what would be the next available IP address? We were given the base network address of 24.0.24.0/23. It had 9 bits in the host portion. Therefore, we could have 512 IP addresses. We allocated 256 IP addresses for LAN B. We allocated 64 IP addresses for LAN C and 64 IP addresses for LAN A. We technically have 128 IP addresses available in case we need to subnet the network further.